So what we're looking at today is arithmetic sequences. We started looking at the patterns yesterday, the difference between an arithmetic sequence, a geometric sequence, and then other types of sequences. So arithmetic sequences is a sequence in which each term is found by adding a common difference to the preceding term. It could be positive, it could be negative, but it's always in the terms of adding. So that one example that we had where the temperature went from 8 to 4 to 0 to -4, I added a -4 each time. So I can look at it as subtracting 4, but I would have to express it as adding a -4. So if we look at this first example, I have the sequence 7, 10, 13, and 16. How do I get each subsequent term in the sequence? I add 3. So now if we look at the algebra that's written here, calculating the difference, t of 2 minus t of 1. What it means is take the second term and subtract the first term. So the second term is 10, the first term is 7. 10 minus 7 is 3. The third term minus the second term. The fourth term minus the third term. What do you notice about all my numbers? They're all 3s. So if you notice, there's a common difference between each of these successive terms. The common difference in this case is 3. And that's how I can find out what the common difference is in my arithmetic sequence. I can just take any two terms side by side, so any two successive terms, and just subtract them. And if I subtract them, I'm going to get the common difference. And it won't matter if I subtract these two, or these two, or these two, or even if I go down here and subtract those two. It's always going to be 3 for my common difference. So if I look at class example number 1, I have the sequence 16, 13, 10, 7. What would my common difference be? -3. Because I would take any two terms and subtract them. And it's always the first term subtracted by the preceding term. So the second term minus the first term, or the 7th term minus the 6th term. So in class example number 2, for each of the following, we want to determine if the sequence is arithmetic. And if it is arithmetic, we want to find the common difference. So the first sequence, 2, 4, 6, 8, is that arithmetic? Yes. So what would my common difference be? Okay. So my common difference would be equal to 2. What about 1/2, 1/4, 1/8, 1/16? Is that arithmetic? How could I check?
Subtract the difference between two different places and see if they're the same.
Exactly. So if I go 1/4 minus 1/2, so if I think of decimals, 0.25 minus 0.5 would be -0.25, and 1/8 is 0.125. So if I go 0.125 minus 0.25, am I going to get 0.25? So is this arithmetic? No. This is actually geometric. I can multiply by 1/2 each time. Okay, what about C? 10, -4, 2, and 8. Is that arithmetic?
Yeah.
How did you figure it out, Bobby Ann?
Well, I just noticed something go up by 6 each.
Going up by 6, and that's my common difference. And again, 8 minus 2 is 6. 2 minus a -4 is also 6. And the last one, 4, 8, 16, and 32. Is that arithmetic?
No.
Why not?
Doesn't it double each time?
It's doubling each time. My common difference is not consistent. This one is 4, this one's 16, this one is, 8, and then 16. So my common difference has to stay common. So in an arithmetic sequence, we have some terminology. The common difference, we use the letter D. The first term of a sequence, I can use either the letter A or T of 1. T of 1 for the first term, or the letter A can also mean the first term. So if I look at class example number 3, what is the value of A in the first sequence? -8, because A is the first term. D is my common difference. So what is my common difference in this sequence? 10. Okay, if I look at the second example, what is the first term of the sequence? So that's my A value. And my common difference this time? -5. Good. So if you remember when we were graphing arithmetic sequences, what did we notice about our graphs? They were linear. And a linear graph has an equation to it. We learned how to write those equations last year when we did slope, y-intercept, point slope form, all of that. Which means if these are linear, I can write an equation. And that's what we're going to develop, is how can I write the equation for any term? Not just how would I find the first term, the second term, or third term. How would I find the 20th term without having to write this out up to 20 times? Because I don't want to have to write it out 20 times. I could, but what happened if I asked you for the 200th term? Don't really want to write it out 200 times. So if we look at the sequence, 2, 12, 22, 32, 42. What's the first term? The second term? The third term? And the fourth? The fifth? What's the value of A? 2. A is my first term. And what's D? 10. So D stands for difference, common difference. So now if I list my T1, 2, 3, 4, 5, and T of 1 is 2. That's the same as my A value. To get the second term, I start with the first term and I add 10. Right? So that's the same as taking the first term and adding one common difference. To get the third term, I can start off with 2 and add 2 common differences. 2 tenths. How would I get the fourth term starting with the first term? So I'd start off with 2, and then what would I have to add? 3 of those common differences, 3 of those tenths. That would give me my 32. In terms of my letters, that would be A plus 3 of those D's. And then to get the fifth term, or the 42, I would take 2 and add how many common differences? I'm getting deaf. You have to speak louder. 4. 4, thank you. And that would give me my 42. In terms of my A's and my D's, it's taking my A value and adding 4 of those common differences. So if I wanted to skip now to the 30th term, how would I find the 30th term?
2 plus 29.
Plus 29 differences. So what would I get?
200.
Okay. What do you notice about the relationship between the number of differences and the term number of my sequence?
The number of differences is 1 less than 2.
It's 1 less. So if I look down here, it would be A plus 29 of those D's. So T of n stands for the nth term, meaning it could be the 4th term, it could be the 8th term, it could be the 29th term, it could be the 290th term. It just stands for the nth term. It could be anything. It's my formula. It's going to give me my general formula. So in terms of my sequence, my nth term would be starting off with 2, and then my pattern is always 1 less than the term number. The term number this time is n. So it'd be 1 less than n of those 10s. In terms of my A's and my D's, we'd be taking the A and then n minus 1 of those D's. Now I could clean this formula up by using the distributive property in here. 10n minus 10, which would give me 10n minus 8. And I could use that formula in this simplified form to find all of my terms. In terms of t of 30, 10 times 30 is 300 minus 8, 292. So in this case here, the n matches up, whereas the common or the number of differences is always 1 less when I'm looking at my pattern. So this is my formula for calculating the general term of an arithmetic sequence. You will have this formula given to you. You're not expected to memorize the formula, but the formula is take the first term and then add n minus 1 common differences. That will give me the nth term. So what we're going to do is we are going to look at some examples. The statement down here, the general arithmetic sequence, A is the first term, A plus D, that's A plus 1 common difference, A plus 2 common differences, A plus 3 common differences. That's what I have right here. A plus 1 common difference, plus 2, plus 3, plus 4, and so on. Okay, 2 examples and then some questions to work on. Consider the arithmetic sequence that is -6, -1, 4, and 9. We are going to determine the formula for the general term of the sequence. So the formula is T of n equals A plus n minus 1 times D. I'm not sure if you did this in physics or with using other formulas, but when you have so many variables, sometimes it helps to list the variables on the side and fill in what you know about each of them. So is there a variable that you know the value of? Is? Okay. Is there anything else I know about the sequence? D is what? 5. And if I'm finding the general formula, I won't know what n is, because n could be anything. So I know what my A and my D are. I can substitute those in. -6 plus n minus 1 times 5. And then like I did in the last example, I would clean it up. Remove the brackets, collect like terms. And I would get 5n minus 11. That would be my T of n, the general term. So then if I'm asked to find the 12th term of the sequence, T of 12, I could then substitute 12 in for n and solve. And what is 5 times 12 minus 11?
49.
Pardon?
49.
If you notice, the 2 n's here match up. The T of n, n is 12, n is 12. The other thing to note, if question B had been the only question that you had given that sequence, I could use this formula. I would be finding the 12th term of the sequence, T of 12. That would be equal to the first term plus 12 minus 1, 5. That's 5. So then I would have -6 plus 11 times 5 Negative 6 plus 55, and I would still get 49 for my answer. So it's not, okay. So class example number 5 wants you to find the number of terms. Meaning if this is the first term, this is the second term, this is the third term, what term number is this? Is it the 18th term? Is it the 20th term? Is it the 30th term? So if I use my formula, that's my formula. So then I'd want to list all of my variables and try to fill in what I know. So what do I know?
A is 3.
Okay. D is negative 4. Do I know what n is? Because n represents the number of terms. Do I know how many terms I have? T of n, do I know what the nth or the last term in my sequence is? So I do have a value because the t of nth term is the numbered term that I'm looking for. So it does match up. So if I substitute in, there's my substitutions. Negative 117 equals 3 times n minus 1 times negative 4. Remove my brackets. And I would get 3 minus 4n plus 4. So I get negative 117 equals 7 minus 4n. Then what would I do? Okay, so if I subtract 7 from both sides, I will be left with a negative 4n on the right side. And what will I be left with on the left side?
Minus 1.
Okay. And then to get n by itself, what would I do?
Divide by negative 4 on both sides.
Okay, and if I divide by negative 4, what do I get? 31. So there are 31 terms in this sequence. Is this an infinite sequence or a finite sequence? Why is it finite?
Because it has an ending.
Because it comes to an end. Good. Okay, so these are the questions that I want you to work on for probably about 20 minutes or so. So 1B and D, 2B and D, 3B, 4, 7B, and 10.